An equation in quadratic form is one that can be written and solved just like a true quadratic after making a substitution. The substitution that we're looking for is a variable expression, and in this case it's going to be x to the negative 1 power, whose square is also in the equation. Let's notice that if we were to take x to the negative 1 and square that quantity, when you raise a power to a power, you multiply the exponents and we get x to the negative 2. So x to the negative 1 is an expression whose square is also present in the equation. So we're going to let u be equal to that expression. So u is equal to the variable expression whose square is also in the equation. And then we're going to make that substitution in the equation. So we're going to let x to the negative 1 be equal to u. And as a result of that substitution, we'll see that x to the negative 2 is going to end up being u squared. So let's go ahead and make that substitution. To get 2u squared minus 7u minus 4 is equal to 0. So an equation in quadratic form is one that when we make a substitution for a variable quantity whose square is also in the problem, we come up with an equation that is truly quadratic, and therefore we can use our quadratic methods to solve it. So we've made the substitution, and now we're going to solve this resulting quadratic for the variable that is present, which in this case is now u. And let's use the grouping method, or the AC method. So we multiply a and c together to get 8. And we're now looking for two factors of 8 that are either going to add or subtract to the center term. And if this sign here is negative, that tells us that the factors of 8 that we're looking for are going to subtract, not add. So the two factors of 8 that subtract to the center term 7 are going to be 8 and 1. We now expand this center term so that it's a combination of 8 and 1. So the 8 has to be negative and the 1 has to be positive in order to ensure that we're going to get a negative 7 out of that subtraction. So we rewrite negative 7u as negative 8u plus 1u. And then we just copy down minus 4 is equal to 0. From here we use the grouping method. We're going to group the first two terms together and group the second two terms together. The factor that's common to the first two terms is 2u. So we pull that out. When we factor 2u out of this first term, it's essentially the same as dividing it by 2u, and what remains is going to be just 1u. When we factor the 2u out of the second term, again, essentially it's dividing that term by 2u, and what remains is negative 4. And now close the parentheses. Now in this second group, we don't have any common factors, and we also already have the u minus 4 binomial that we're hoping to remain out of that second group. And in this situation, we want to use a plus 1 placeholder, meaning there was nothing that we ended up factoring out of the second group, but it helps with the next step if we put a plus 1 placeholder here so that we can see what remains when we factor out the u minus 4. And so let's do that next. Here we have a big term with a factor of u minus 4. And here we have another big term with a factor of u minus 4. So the u minus 4 common factor can be pulled out, and what remains from the first term is just going to be 2u, and what remains from the second term is this plus 1 placeholder. We're still in this process of solving the equation for u, so now let's set each of these factors equal to 0 and solve them individually for u. So we add 4 to both sides here and get that u is equal to 4. We'll subtract 1 from both sides here to get 2u is equal to negative 1, and then we divide both sides by 2 to get that u is equal to negative 1/2. Now it's time to do what we call back substituting to x. Remember, the original direction said to solve for x, and what we've currently done is solve for u. So now we need to back substitute to get back to the original variable and then solve for x. And the way that we do that is that we're going to use the same substitution that we used to get from x to u. So we currently have that u is equal to positive 4 and u is equal to negative 1/2. When we back substitute, we say that if u is equal to x to the negative 1, then those two values are interchangeable. So I can replace this u with the x to the negative 1 that it's equal to, and then I copy paste the right hand side. I can replace this u with the x to the negative 1 that it's equal to, and copy paste the right hand side of negative 1/2. So now we've returned to the variable x, which is what we were originally trying to solve for. In order to solve for x here, we need to get x raised to the positive 1 power, and we can do that by raising both sides to the negative 1 power. When you raise a power to a power, you multiply these exponents. So on the left here we get x to the now positive 1 is equal to 4 raised to the negative 1, and that's the same thing as 1/4. So positive 1/4 is one of our solutions. Let's do the same thing to the other side. We'll raise both sides to the negative 1 power in order to get a positive 1 power on our x. And on the right, we now have negative 1/2 raised to the negative 1 power. When we raise something to the negative 1, we basically reciprocate it. So the reciprocal of negative 1/2 is negative 2, and so x is equal to negative 2 is the other solution to this equation. To check our answers, we can put our solutions into a graphing calculator, starting with 1/4. We can say 1/4, store that quantity into x, and hit enter. And then we can plug that value back into the original equation, or essentially type in exactly what we see into our calculator, which is 2x raised to the negative 2 power minus 7x raised to the negative 1 power minus 4, and then we hit enter to see that this x is equal to 1/4 solution does work. The other solution was x is equal to negative 2, so we can do this again just by plugging negative 2 into x. So we come back to our calculator and say negative 2 store x, and then enter. And then again we can retype this equation, or we could just hit the arrow key and climb up a little bit to highlight the equation that we already plugged in. If you hit enter from here, the calculator will copy paste the equation that you've already entered. And then now if we hit enter again, it will recycle this equation, but this time with negative 2 stored in for x. So we hit enter again, and it says that even with x is equal to negative 2, this equation turns out to be 0, which tells us that our two solutions actually work.